companies in the world that I've had my eye on for a very long time. There's all these videos on the internet of these amazing explosive demolition projects, these power stations, these stacks. There's one, their stacks implode into each other.
Yeah.
And one company's behind all of these videos, and that company is Brown & Mason. First exploding, see what I did there? Onto the scene in 1961, Brown & Mason is one of Europe's largest demolition contractors, taking on some of the biggest projects anywhere. I have watched their stuff online for years because what they do isn't just your average knocking stuff over. They often use explosives to fell power plants, stacks, and cooling towers. Today, we're in England visiting two of their power plant demolition projects, one a few years into the project and another not so far along. And that's the one we're checking out first, seeing a fleet of excavators munching away at the plant to prepare for an eventual implosion. So with that, let's get out to the site and check it out. Like any demolition project, everything is recycled. Power stations are absolutely no exception. So all of the machines behind me are extracting that steel for the sake of recycling. Here we have a magnet, a giant magnet that picks up the ferrous metals, the metals that are magnetic. It picks them up, it puts them into this bin, turns the magnet off to drop them in the bin, and then this truck, or lorry as the British would say, is going to haul it off to the recycling area. Such a massive building yields massive pieces of steel. That 1200 is yanking them out of here with no issue, but they're too big to go in the trucks. So we've got this 995 Lugong with a snippy snip on there. That snippy snip is there just to cut up all of these pieces of steel into more manageable pieces so that they can be loaded into the trucks and hauled off a lot easier. So that is a critical piece of equipment, and you can see that thing is having absolutely no issue getting through even the biggest hunks of steel.
What was this?
So this was the gas turbine house. So we just dismantled mechanically, and now we're going to extract the turbines themselves.
Okay.
And then we're looking towards the explosive collapse of the gas stacks later on this year. And that should come into this direction when we've processed all of the precipes,
Okay.
freeing up some space to then further collapse parts of the structure this way.
Yeah. Well, and when people hear explosive demolition, they just assume you guys just come in here and put dynamite everywhere and just blow it all up.
Yeah.
But there's a lot of work that goes into getting it to that point.
A lot of preparation. There's far more preparation. I mean, like, the actual explosive event is sort of takes 2 weeks of on-site preparation, but of charging. But there'll be months and months of backroom and pre-engineering work that goes into the actual project to be completed.
Okay. The stacks will eventually be imploded as well.
Yeah, so they'll be brought down explosively. Probably one of the last structures on site when we freed up some space for them to collapse into, because we've got the proximity of the overhead power lines.
Yeah. That is quite close.
Yeah.
How high are these?
These are about 260 metres.
And you'll do one at a time?
It depends on what we decide at the time. So the site itself, it's a large site, but there's a lot of stuff going on, and proximity of other structures is an issue regarding explosive collapse, but that's where the pre-engineering comes in.
And the engineering helps decide where the structure goes.
Yeah,
when you blast it.
Direction it falls, how it'll break up as well, because ultimately we've got to leave it in a state that can be processed mechanically. By explosive collapse, you're trying to eliminate the working at height risks and other issues associated with that.
But if you do it incorrectly, then you have an unstable structure.
Yeah.
That's even more dangerous.
Potentially.
Potentially, yeah.
Yeah.
So that's why you need to plan so much.
Yeah, a lot of structural assessment and engineering will go into that process.
Yeah.
We're looking like 12, 14 months ahead on structures that we're going to explosively collapse.
I'm not compensating for anything. What are you talking about?
While this may look like welding to the untrained eye, it's the opposite. Meet the gas axe, formerly known as oxy-fuel cutting. Let's check it out a bit closer.
We saw the giant mechanical snippy snips over there processing a lot of the steel, but there's so much that comes out of the power plant that those giant machines can't tackle, and that's when this operation here takes over. These are guys with the gas axes, acetylene torches, cutting up the bigger pieces. They get more value for the steel if they cut it down, because that makes the processor that they're selling it to happy. They can process it a lot easier. So they're trying to balance how much time they spend on site cutting this stuff apart versus what they send in whole pieces. So these guys, this is hard work, but really, really critical stuff, because they're making it possible for all of this to be recycled a lot easier.
Before we head to the main structure at West Burton, let me provide some context. Brown & Mason is world-class at deplanting, meaning they systematically dismantle whole power plants. The building we're entering has 4 main power packs. Eventually, they'll implode the entire structure, but there's a lot of work before they let it rip.
So where are we right now?
So at the moment we're in the turbine hall, unit 3. And what we're doing here, this used to be filled up with all condenser packs, the stator, etc. So what we've done is taken the casing off, obviously it's gone now,
Yeah.
and worked our way all the way down into the void, taking each condenser pack out singly, and then now what we're doing is taking out the side walls and eventually the floor at the bottom.
So it's a lot of handwork in here.
More so with the gas axe, with the obviously propane cutting techniques.
Is that the actual turbine right there?
Yeah, see where we've cut the shaft
Yeah.
there? It would come all the way along here. And this blue casing, that would sit on top.
Oh, okay.
But obviously that is all gone.
Oh, I see. This is what made the power, the turbine.
Yes. This is the important part of the light.
Yeah. But you guys have to, the job is to systematically disassemble it.
It's called deplanting. So what we
Deplanting.
do is we deplant the turbine hull, and then eventually every single unit will have all the condenser packs out, all these side walls, all these pipes you see will all be gone, and then that will allow us to prepare the building for a blowdown event.
And so once you get it down to a certain elevation, can you use the equipment to do the rest?
Yeah, once you've taken out all this thick steel, the floor,
Yeah.
the pipe work, then the machines will come in.
And then the goal is to remove everything from this building,
And it will just be a shell.
a shell, and then that's what you implode.
Yeah, that's when we start prepping the building and it's float down.
Wow. And power, this whole thing was to really just spin that.
Yeah, with steam.
That's amazing.
When they come out, you see the size of them. Massive.
It's remarkable. I've never been in a power station like this, at this stage.
As we progress down further, you'll see it's not as far advanced as this one.
Okay. So you have to do this kind of work at all 4 of them.
Yes, every single one.
That's a lot of work. That's a lot of
And
cutting.
it's exactly, oh, it's a lot of work, yeah. And it's exactly the same process on each one. So what we've done in here is we've started prepping all the pipe work, all the gantries, all the stairways with oxypropane cutting techniques. And then what will happen is the machine will then come in and start demolishing it.
Okay.
And then we will then slowly progress all the way down to the end. All that steel will be gone. And yeah, just follow a process.
And the boilers made the hot water steam,
Yeah.
which
pumps it
then
through the
pipes in
turbine
here, spins the turbine,
and then creates power.
creates power. It is amazing. All power is just spinning something.
Yeah, I know.
All right.
It was 12 condensers in here, wasn't it, initially?
Yes.
Each connected up to one of these pipes. Then you had your shaft through, which had your turbine.
The casing on the top.
You just turn the light switch on, you don't think about it.
Yeah. A lot of maintenance as well goes into running this place when it's live.
Oh, but and even just how much time and effort it takes to dismantle it all. I mean, it's
Yeah, because how long we been in here now?
We started like mobilising and doing a few things at the back end of 2023. So we've been here
so half a year.
about 9 months.
Yeah.
No, about 9 months fully.
This is the boiler house, a very key portion of the power plant. The coal comes in here to these silos and they use the coal to create heat. That heat then heats up the water to create steam. That steam spins those turbines to create the power. This is an enormous structure, a few hundred feet high. They are working through it right now to strip the asbestos and then they'll prep it for implosion. The implosion is pretty spectacular and they've done a few of these before, so let's cut to some footage. Pretty cool. This is where the magic happens, so to speak, for power plants. This is where the power is generated. So there were 4 massive generators within this building, all using that steam the power plant was producing to spin those turbines, which creates the power. Power is all about, except for solar, spinning something, whether it's wind, it's coal, it's gas, you're trying to spin those turbines. And here were the massive turbines. before they demolish this entire building with explosives, which is quite fun, they have to clear it all out. And clearing it all out requires a lot of handwork. So they have some machines in here, but these are the biggest machines they can get in here because there is a basement below us, so you can't put too much weight onto here. And everything above these machines is down to people with baskets and man lifts and axes to dismantle before they can bring this entire thing down, and that's what we're checking out. We've seen up there them dismantling the turbines from the top down, but once they get close enough to the ground, they can switch over to the heavy equipment, which is a little bit faster. So we have the excavator here with a muncher chipping away at the concrete and separating out the steel and the rubbish so that they can haul it out of here and clear some more room.
Now let's roll to the Cottam Power Station, a similar project that's much further along in the process, where they're sorting materials and cutting scrap. Oh, and it's where Big Red's on the loose.
This is the second power station, only about 15 minutes from the first power station we were at today. The first power station needs a lot more work. They'll be there for many years. But this one, they've been here for many years and they've made tremendous progress. So where the generators were and the boilers were that we went in at the last power station that was almost fully intact is right behind me. This is where they were. They imploded them about 5 months ago. And now they're processing the material. This is what it looks like after 5 months of processing. There's still so much steel to sort through. There's a lot of work required to get a building like this ready for demolition because of this right here. They want the building to lay down in a very specific way so that they can effectively process it then with heavy equipment without it being unsafe. So they cleared out that bottom level and then they cleared out the building in such a way that when they blasted it many months ago, it was able to fall in what we have right here in this manner. So all of these tubes now that the 995 is cutting up behind me are the boiler tubes. There's a few different units here, 4 different units. So he's working on one of the units. He's going in there very carefully, snipping away at those boiler tubes, putting piles down on the ground, and then that 870 is coming along, grabbing those piles, stockpiling it over here. We've got smaller machines then processing it further, cutting it into smaller pieces. That's then loaded into trucks and hauled off. An example of the boiler tubes, unprocessed, just pulled from the pile, stacked up, and that's processed, ready to go onto a truck.
are cooling towers, which leverage airflow to remove heat from the plant's water. I've seen some wild stuff worldwide, but I'd say this was one of the coolest places I've ever visited. Let's go into the tower to learn how they'll eventually implode them.
Well, I guess give your best explanation.
So we're now at the 15-meter level,
Yeah.
which is above the packs and mist
In one
eliminators.
of the 8 cooling towers.
Yeah, so there's 8 towers on this site,
Yeah.
2 for each boiler, effectively.
Okay.
And the actual structures themselves are 100 meters tall. Like I said, we're now at the 15-meter level. Below us here, you've got mist eliminator, which is like a honeycomb plastic material that ultimately reduced the amount of steam that came up into the tower itself.
Okay.
And then it was just a natural draft system that cooled the mist in the tower itself.
What is
Condensed.
why is the cooling needed?
So, opposed to a site that's near to a large body of water or sea, the requirement on the water course locally would have been far too much for it to cope with.
Okay.
So they needed to retain as much water on site and recirculate it rather than keep extracting from the Trent. And ultimately there was West Britain's on the same water course as well, so you would have had 2 stations requiring a lot of water every day.
Okay. So instead of using a huge body of water to cool the plants.
So yeah, if you're near the sea or a large lake, you would
Yeah.
just have an inflow and outflow out in the sea or lake, and you would just draw the water straight from the lake, go through the system, and then they discharge the warm water back to the lake or sea. Whereas,
Well, what do you have to cool?
To answer my question after the fact, the power plant produces hot water which needs to be cooled first before being recirculated. Hot water enters the cooling tower about where we are in this clip, a few stories off the ground. It then hits a heat exchanger, which allows the air from the bottom of the cooling tower to pass through the water, grabbing the heat and bringing it up the top of the cooling tower and eventually out. From there, the water drops down into a pond below where it is cooled and ready for recirculation.
So most of the structure is really just this concrete,
yeah.
these concrete circles that just get narrower and narrower and narrower.
So this is all continuously cast concrete, shuttered and cast.
Okay.
So this is basically the squares you see are sheets of ply.
Okay.
Would have been for shuttering.
I see.
And yeah, they just continuously cast it up to the top.
So what you guys are doing, this will be imploded
Yeah.
in what, next
So-
year?
Yeah, beginning part of next year.
Beginning part of next year. And so to get it ready, you're clearing out everything below us.
Everything below. So you've got the silt in the pond itself. We already removed 40,000 fish from the site initially, drained the ponds, and now we've started removing the silt in the towers. We're into the 3rd one now.
Before we continue here, let's check out the biggest earth-moving operation on site, the operation to clean out the ponds at the bottom of each cooling tower.
This is cooling tower 3 to provide more context. We were standing above the level that's above us right now. All of these supports are eventually going away to make way for the demolition process of this cooling tower and all 8 on site. There's 36 pieces of plant, which is what the British call heavy equipment, but these are the most important.
And the first one, we're removing the support structure for the packs.
Okay.
Once that's all removed and the plastic goes for recycling, the concrete goes back to be crushed for use on site, and then we will sort of take control of these structures then for drilling for the blasting process.
Okay.
So we'll be drilling about this sort of height.
Okay. And you'll be drilling holes all the way around the structure?
In certain sections.
In certain sections. And you'll put the explosives into those holes?
Yeah, place the explosives in those holes,
Okay.
connect it all up, along with a proportion of the columns below our height now.
Okay. So you're essentially just kicking out the bottom and allowing it to fall in on itself?
Yeah.
So gravity does most of the work?
Yeah, and introducing effectively a stress raiser in the shell itself.
Yeah.
That then just continues the collapse of the shell itself.
Okay, so the collapse starts from the bottom and then works its way up as it falls into itself.
Yeah.
Wow.
So ultimately everything above this level collapses under its own weight.
Okay.
But we induce that stress raiser through explosives initially.
Yeah. By essentially dropping it.
Yeah, and we'll drill a band at this height as well.
Oh,
in the shell itself.
Okay,
So basically put a failure in the shell explosively, and then that continues throughout the rest of the structure.
That's quite cool. And you'll blast them all simultaneously?
At the same time, yeah. There'll be fractional delays between all of them.
Wow. And then all you get's a pile of concrete?
Then you're left with a pile of concrete. A lot of crushing.
Excellent.
But how do they recycle all of this concrete? Well, let's check it out.
We've seen what happens with the steel and metal, but what happens with all of the concrete on a site like this? It ends up at the on-site crushing operation. We've got an excavator with a magnet digging through the pile here to dig out the bigger pieces of metal, putting them in a pile there, and then that excavator comes behind them, grabs a bucket, feeds it into this crusher, which cuts up anything, rock, metal, whatever. There's a magnet spinning on that crusher at the other end of it before it hits that conveyor. It pulls out the ferrous material as we go, and we end up with a pile of crushed concrete. That concrete, most of it stays on site because this entire building has an enormous basement underneath it that needs to be filled up, and that right there, perfect material without needing to haul anything on or off site.
You want to know why I pulled you over? Littering.
Officer, that's not ours.
Candy bars.
Thank you very much to Brown and Mason for having us out and showing us both plants. It's kind of nice we're in Britain. Everything's a lot easier to pronounce here. Barnrather Duraline. Amazing company.
And before you go, if you liked this video, please subscribe, turn notifications on. We have new videos coming every Saturday morning, and we'll see you next time. Stay dirty.